Okay, if you guys read the hinge theorem, it's a lot to read. And when you're describing something like this, it's going to be a lot to read. The hinge theorem states if two sides of a triangle are congruent to two sides of another triangle and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Okay, what does this mean? Well, the moral of the story, I guess you could say, is that, okay, we've got two triangles here. And everyone look up here. Don't worry about writing. They're saying, and in these two triangles, they happen to have two sets of congruent sides. Now, everyone look up here. But in these two triangles, they're saying the angle that the two sides, the included angle, that the two congruent sides make, one of them is bigger than the other. So let's say this one was 110 degrees and this one's 90 degrees. If these sides are the same, then wouldn't it make sense that in the 110 degree angle going to hold a bigger side than the 90 degree angle? Isn't this just building off a little bit of what we did a couple sections ago? But the key to this whole deal is the fact that the sides that make up the angle are what? What are they saying? Congruent. Yeah, their measures are equal. So and then of course the opposite is true. The converse is true as well, and that's that if this side's smaller than this side and these two are congruent, then this angle must be smaller than what? That angle. Okay? So what I'm going to say, the hinge theorem is basically saying if two sides of two triangles are congruent, let's say then the triangle with the larger angle makes contains the larger side. Yeah, the way even on something that's that long and that dependent on so many different factors, it's going to get a little wordy. Probably the key is to realize that doesn't this kind of make common sense, it's just common sense that if these two arms are the same length, and that's basically what's happening here, isn't it? The one that's opened wider is going to hold the wider what? Distance, is it not? And I think if you understand that concept, that's a lot easier than trying to remember the long words that go with it. Okay? Let's get out your workbooks and let's do some examples. And let's apply this a little bit. Where's yours? Yours is what? Okay. Does it have 5, 6 in it? They only give us so many of these, so I don't want to use it unless I have to. No, you can't. You have one. Oh, yours is fine. Let's look at page 69. Page 69. Here we go. They want us to compare the given measures. Well, BXA. They want us to compare this one and DXA and this one. Now, this is congruent to that, is it not? And we're talking about, we're going to compare this angle and this angle, right? And isn't this congruent to itself? It's a common side, is it not? So which angle has to be bigger? The one on the bottom or the one on the top? Why? Because the two arms are holding a side, what? They're holding a side that's 8, where this one's only holding a side that's what?
6.
The two equal arms, these are the two arms holding, right? And they're both arms are the same length. This one is opened up a little wider than what? That one is, isn't it? So the larger is AXD. So when they say compare these, you would say the measure of angle DXA is what? Greater than the measure of angle BXA. And that is the only way you can write that answer unless you flip it. But when you're doing these problems, I expect to see an inequality as an answer, not DXA. Or DXA is bigger. Measure of angle DXA is larger than, I guess if you want to write out the sentence, the measure of angle DXA is bigger than the measure of angle BXA, have at it. But to me, that would be, take you less time, would it not? And here it says, let's compare BC and DC. Well, I knew this one right here is bigger than this one, right? Well, then this one is going to be bigger than this one, is it not? Because see, what's left out of 180 is going to be what? Less here than what's left here. Because here, for instance, if we're saying this one, sometimes when you're dealing with things that are kind of conceptual like this, or it's better to put some numbers in there to understand it. What we're saying is that this one is bigger than this one. We know that for a fact, right? So that, let's say, what does that one look like it is? 95 degrees. So that would make this one 85. Well, then what would it make this one? What would be left here? 85, and what would make this one? And also these are vertical angles, right? So if these two are congruent, then this angle's got to be bigger than what? This angle. So this side, BC, has to be bigger than what? DC, doesn't it? So that's what we need to write here. BC is bigger than DC. Compare the given measures here. They want us to compare STR, They want us to compare this angle with TRU, with this angle. Okay. They share a common side, do they not? And the other arm of the angle is equal, is it not? So the arms are equal here, aren't they? Which angle has to be the bigger? The arms holding 30 or the arms holding 31? So I would say the measure of angle what? STR is greater than the measure of angle what? Okay. For this next one, they want us to compare PQ, that's this one right here, and RQ, and that's this one right here. They have a common side. Both arms the same length. If the arms of each of the angles are the same length, then the one with the larger angle is holding the larger side. So which one's bigger here? So PQ is greater than what? QR. RQ or QR. Not so bad, is it? Okay, your assignment. Do. End of the hour tomorrow. Numbers 1 through 4, 10 through 15, 17 through 20. Write the problems, draw the figures, and that includes labeling them. And show all steps and work. You hear about the labeling them, putting what things are equal to, marking them, how they are in the book. I hope you heard that. Nothing. There's your assignment. As you can see, is that a large assignment? Not at all.
Well, it depends how much we have to write down.
You better write every single bit down.